Number 27 was another problem we didn't do real well on as a group here. Only 29% of us in this practice test we took last week got this one right. It's kind of a strange wording of what is really a related rate problem, and I think once we realize that, we're gonna come to the conclusion that this is probably actually easier than most related rate problems we deal with, where there's a diagram and they show you something moving and you've got to figure some things out. What they've done here is they've given you this weird implicit equation right here relating the variables p and c. P squared is equal to 20 minus c, all taken to the third power. They've given you the value right here, but notice what it says at the instant when. So what we're dealing with here, guys, dp dt equaling 41 and c equaling 15, those right there, guys, to use a phrase that we talked about back in the end of chapter, well, that was the end of chapter 4, although it's actually section 3.10, those are what I called TSVs. Those are time-specific values, which means you can never use those values until after you've taken the derivative of this equation. Now, we don't usually do related rate problems with implicitly defined equations, but that's exactly what we're going to do here, guys. Notice the derivative that they gave you right here, dp dt, was taken with respect to t. So we're going to differentiate both sides of this equation with respect to t, which is what we pretty much always do in a related rate problem. So the derivative of p squared is going to be 2p, but because we're not differentiating with respect to p, but rather t, we've got to put a dp dt as a factor at the end of that right there. This is the chain rule. And now on the right side, we've got something to the third power. So the derivative of anything to the third power is 3 times the same base, unchanged, 20 minus c, drop the power by 1, that's a square, and then we need to multiply now by the derivative within. And the derivative of 20 minus c, well, the derivative of 20 is 0 because it's a constant, and then the derivative of that minus c would be a negative 1, but then multiplied by the derivative of c with respect to t. So there's a minus or a negative dc dt here used as a factor at the end. So that's the implicit differentiation we need to do. And now what I think happens at this point right here, guys, is that we have, if I'm counting correctly, 1, 2, 3, 4 variable quantities within this setup right here. Now, the one we are trying to, boy, I've made a mess of this. Let me go back to where we were here just a second. We are trying to find the value, here we go, of dc dt. This is the unknown here. And that means, guys, that we better know a value of p, of dp dt, and a value of c. And it's okay to use time-specific values now that we've already differentiated. That's what that dotted line denotes for me. So what are they telling us right here, guys? Well, I can read pretty quickly that dp dt at this moment in time is 41. So I'll put that right there. What else? They're also telling us that c is 15. So this is 3 times 20 minus 15 quantity squared. We're not supposed to know the value of dc dt. Although, guys, one thing I am going to do to make my life easier, I'm going to bring that negative out in front here and make that a negative 3 and then multiplied by a dc dt. The big quandary right here, what's up with p? We need to know the value of that, and they didn't tell you that. Well, here's what you have to do to find that piece of information. The original equation right here that relates p and c, well, if they gave us the time-specific value of c, we can use that information to find p. So, I didn't leave myself a lot of room, but let's see if I can cram this up here in green. The original equation now, p squared is equal to, that's going to be a 20 minus 15 quantity cubed. Interesting. So p squared is, that's a 5 cubed, which is 125. And this is a little ugly here, guys. P then is the square root of 125. And they gave you a number here. This was a choice. They could have made this nicer. They gave you a number here that wasn't a perfect square. I think if I were writing this problem and I wanted to be nice to you guys, I might have made c equal to 16, and let me tell you why. Then what we did right here would be 20 minus 16 cubed. 4 cubed would be 64, and 64 is cool because it's a perfect cube, but it's also a perfect square. And then when you took the square root of that on the next side, you would have just gotten 8. But they must have been doing this on purpose. So the square root of 125, guys, is going to simplify here to a 5 root 5, because that's 25 times 5. So, okay, that is the time-specific value of P that goes along with this time-specific value of C of 15. So out in front of this whole thing, I've got a 2 multiplied by a 5 root 5. So let me just put that right there. Okay, guys, and that completes everything that we needed to find right there at this particular moment in question. We know the value of P, the value of dP dt, and the value of C. So now we can work on finding dC dt. Whew. All right, let's clean up this left side. The 2 times the 5 right there is going to give me a 10 times 41 is a 410 times the square root of 5. Whew, this is ugly. What else? 20 minus 15 is 5. 5 squared is 25 times a negative 3 is negative 75, and then a dC dt. Okay, let me switch back to red here. I'm going to divide both sides by a negative 75 right here. This is a pretty healthy, and by that I kind of mean unpleasant, amount of grunt work to do by hand here without a calculator. Sorry about that, guys. All right, so what I see here is that the 410 and the 75, well, they look like they can both be divided by 5, I suppose. Let me think, guys. 5 goes into 41 8 times, and then a remainder of 10, so that would be an 82 root 5. 5 goes into 75 15 times, and there was that negative down in the bottom here that I think I'm just going to pull out right there. I don't think I missed anything. I think 82 over 15 is in simplest form, and so it looks like, everybody, that our answer here for number 27 is D. All right, so that is a kind of a tricky related rate problem right there. A little bit harder than I thought when I looked at it the first time, but that's how we handle a problem like that. I think what was difficult about that was decoding it and trying to figure out what type of problem it was. And hopefully if you were able to do that, we're able to get the correct solution here if we see one like this in the future.